Question 73, 2x squared minus 3x minus 35 equals 0. I know it's a quadratic equation. It's got a squared up in it. But how is question 73 different from question 72? And the answer here is the fact that the x squared, the quadratic term, does not have a leading coefficient that is 1, like this implied 1 up here. In other words, the a value is not 1. As ax squared, our a value is 2. When that happens, my suggestion is that whenever you go to factor this thing, you're going to use what we call the AC method. It's called the AC method because it's referring to the A and the C, the first term and the last one, in order to find its little special factor numbers. Just like I did on 72, let me show you this as a foiling thing backwards. I'll start off with some random terms here. How about a 3x plus 2 times x minus, I don't know, 4. Okay, again at random. And ordinarily this thing would be equal to 0. You would set both of those factors equal to 0 and you'd solve those linear equations. However, we're just going to expand this out using FOIL. My first terms, 3x squared. My outside is a negative 12x. My inside is a positive 2x. And then finally, my last term here is a negative 8. Okay, this one's getting on my nerves, so he gets fixed. Okay, and then we would, of course, combine our two middle terms here as a negative 10x, and then bring down the rest of the stuff. So 3x squared minus 8. So really, this is the quadratic expression that you would originally be given that you would have to turn into the factors that are like this. So let's see how this is different from the other factoring technique that we talked about. Okay, so I'm going to pretend like I'm going to do the same exact thing by doing my little factoring game where I'm looking for two things that multiply up to, in this case, I would think negative 8. Let me put a negative 8 there. And those same two things are supposed to add up to what I would expect to be the middle term, which is the negative 10 equals negative 10. Okay, and I'm having a bad feeling about this already because if I'm trying to factor my two numbers here to get a negative 8, they have to be different signs. They have to be different signs, positive times a negative. And if that's the case, they're actually going to subtract. And how am I supposed to get something that's going to be bigger than that 8, right? So as far as my factors go, if I'm looking at factors of negative 8, just ignore the sign and just go with 8. You would have 1 and 8. You could not add or subtract those to get 10. Let's say you'd have 2 and 4. And again, you could not add or subtract those to get negative 10. And that's it. That's all the factors. So something's wrong. Yeah, what's wrong is that we're not taking something into account. And it is the fact that our two middle terms here were negative 12 and 2. Negative 12x and 2x in order to combine together to give us this negative 10. And remember on the previous thing that we did, previous factoring, those two middle terms that added up to the 2x in this case, they also multiplied the negative 3 times the 5, also multiplied up to this negative 15, our constant term here. You know what? The same thing's happening. So instead of these two multiplying our two special factors, multiplying up to negative 8, instead what they're going to multiply up to is negative 12 times 2. That's what it should be. Negative 12 times 2, which definitely doesn't make negative 8. Instead, it makes negative 24. Okay, that's weird. However, they still add up to negative 10. Okay, so where the heck is this? How am I supposed to know where this negative 24 comes from? Uh, is there any indication in the original problem that I would have a negative 24, right? This is the thing that I'd be given. I wouldn't know the negative 12 and the 2 at all. I would only know the 3x squared minus the 10x and then minus the 8. Is there anything that I can do with these numbers to get negative 24? And remember, here's your hint. It's called the AC method, named after the fact that you take the A term and you multiply it times the C term in order to get this product of negative 24. Because that's where these things came from, right? This is where, whenever I multiplied, let's say, whenever I did my little foiling technique here and foiled this stuff out, I would take this negative 3x times the 4 to get the negative 12, and then the 2 times the x to get the 2x. That's where those things came from. So, in order to work this thing backwards, do my factoring step, instead of just using the C term, the constant term, to get my product, I'm going to take my A and multiply it times my C to get the negative 24. And you might be asking, well, why is this one different from the other one? It's really not. The other one is also the AC method. It's just the fact that the leading coefficient up here is an implied 1, and whenever you multiply 1 times negative 15, you still get negative 15 here. So you don't really have to worry about it. But it's not a different technique. It's essentially still the same one, just a simplified version of it. Okay, so now let's see how this thing would work backwards. So I'm going to pretend that I have the quadratic equation 3x squared minus 10x minus 8 is equal to 0. Okay, I would see that my leading coefficient here is a 3. I'm going to use my AC method. So whenever I play my little factoring game, what times what is equal to not negative 8, but a 3 times negative 8, which is negative 24. And those same two factors are supposed to add up to the middle term here, and that always happens, negative 10. So again, I'm going to think of the factors. I know one's positive and one's negative, so they're actually going to subtract instead of add here. What times what gives me a negative 24, and is going to add up to 10. So, I mean, we've already done the factors, so we kind of already know that it's going to be a negative 12 and a 2. We'll do one in a second where, we won't have these same exact hints, so we'll have to guess on the fly. So negative 10 times 2 is negative 24, and negative 12, maybe have said negative 10. Negative 12 plus 2 gives me my negative 10. Okay, just like what we did before, the AC method is still expanding the middle term. We're working this thing backwards here to get these two middle terms, and then we would do the little grouping technique that we talked about before. Okay, so I'm going to expand out the negative 10x as a negative 12x plus 2x. Once again, it doesn't really matter which one of these comes first. However, if one of them is negative, I would suggest putting that one down first. That way you don't run into the situation where you might accidentally chop off the negative sign for the second term. Let's bring down the other two terms. 3x squared minus 8 equals 0. Group up the first set and group up the second set. All right. Now, if you watch through the other video, you might be asking, well, can't I just take these two things and throw them into the parentheses? Well, here, take a look. What happened up here? You can see that sure, there is a 2 there, but there's certainly not a negative 12. So that little shortcut method only works if your A value is a 1. Okay, when it's not, you just have to expand out the middle term like this. All right, then. So now I do my GCF step. What common factor does 3x squared and a negative 12x have in common? And that's going to be a 3 and an x. open up the parentheses, and if I divide both of these things by 3x squared divided by 3x is just x, and negative 12x divided by 3x is a minus 4. Ooh, look at this. This is the same thing as this, so it's working out. Now remember that the second term also has to have an x minus 4 in it, and I can see it. It's hidden in here. It just has a common factor of 2 that I have to divide out. So if I divide both of these terms here by 2, I would get, so 2x divided by 2 is x, and negative 8 divided by 2 is a negative 4. X minus 4, which is what we expected. That's the new GCF. Boom and boom. Factor it out, x minus 4. And if I divide both of these terms by x minus 4, what's left behind is our second factor, 3x plus 2. Apparently this is going to be red. 3x plus 2 equals 0. And you can see that that is nearly identical to what we started with. The factors are reversed, but that really doesn't matter. And then again, I'm going to use the zero product property. Said each one of these things equal to 0. X minus 4 is equal to 0, so x is 4. Over 3x plus 2 equals 0. I'm going to subtract over the 2. These kind of things like this last step here, you could probably do in your head, especially after you do a few of these things and know exactly what to expect. And then I got to get rid of this 3, so I'll divide it over. X is equal to negative 2/3. All right, yeah, and yeah. All right, so this is the kind of thing that I would suggest doing on something like question number 73 that I just marked through, question number 73. If that's enough for you, you go ahead and tackle that problem. If you'd like to see another example, let me show you. Okay, so just from scratch, no foiling backward, or no foiling and then, having something to cheat from. Let's just say I have 2x squared plus x minus 10 is equal to 0. So a couple of things that I want to do is I want to identify it as quadratic. Square term, that means I'm going to have to factor. Since it has a leading coefficient of 2, I don't just use the straightforward method that I did over here. Actually, it is AC method, but this one has a leading coefficient of 1. You don't really have to worry about it. When it's a leading coefficient of 2, then that's going to tell you that you have to multiply that 2 times the negative 10 in order to get a product of 2 times negative 10, negative 20. And those same two numbers are supposed to add up to the middle term, which is the implied 1 that's in front of that. So equals 1. So what times what gives us negative 20 and adds up to 1? So they have to be different signs. The bigger one is positive, and basically they have a difference of 1. They're 1 apart from each other. And those two factors are going to be 5 and 4. Which one is negative? Well, since it has to add up to a positive 1, the bigger one has to be positive, and then the 4 is going to be negative. So 5 plus a negative 4 equals 1, and then both of those factors check out. What do I do with those two factors? I'm going to use them to expand out this x that's right here in the middle. One of them is negative, so I'm going to go ahead and write that one down first to avoid a sign error as a negative 4x, and then plus 5x, and then bring down the rest of my quadratic. Okay, and then do my grouping step, and then GCF. So what is the greatest common factor between 2x squared and minus 4x? That'll be a 2 and an x, and then open up the parentheses. Divide both of these terms by 2x. 2x squared divided by 2x is just x. And then negative 4x divided by 2x is a negative 2. Why are you red? I don't even know. Minus 2. Right, and you can, of course, double check it by just distributing through that, either mentally or writing it out if you want to. Okay, now GCF between 5x and minus 10 is going to be a positive 5. Put the little positive sign there already, like I knew what to expect or something. Open up the parentheses, divide both of these terms by 5. 5x divided by 5 is just x. Negative 10 divided by 5 is negative 2, which is also what we should have expected because that's what happened in this set of parentheses. If it doesn't happen, then chances are maybe you pulled out the wrong GCF or maybe you chose the wrong factors right up here. Okay, almost done. GCF now is x minus 2, pull that thing out. And then the factor that's left over is 2x plus 5, and that's what happens when you divide out the greatest common factor. So 2x plus 5 is equal to 0. Zero product property, so both of them equal to 0. So x minus 2 equals 0. Add the 2 over, so x is equal to 2, or 2x plus 5 equals 0. Subtract over the 5. Divide over the 2. Negative 5 over 2. And there are your two answers. Whoops, where's the 2? Whenever you have a quadratic equation, that's what you're expecting to have is two answers. Linear, you're expecting to have one, but quadratics are supposed to have two. Sometimes they have one or none, depending on, where those roots end up. If you turn this into like a quadratic equation with 2, like instead of a 0 here, you had a y and you graph it as a parabola. Anyway, AC method is the kind of thing that you want to do on question number 73.